Hello everybody, welcome into another lesson. So today we are going to talk about eccentricity of a conic section. So what is the eccentricity? Well, the eccentricity is really just how much the measure of a curve of a conic section deviates from that of a circle. So if you think about a circle, it's perfectly circular. All your dimensions are even around a circle, so its eccentricity is 0. So yeah, and eccentricity is abbreviated by lowercase e, which that's universally what's used. I really wish they wouldn't use e because we know e has an approximate value of about 2.71, but if you see eccentricity and E being used, it doesn't mean the number E. E actually means eccentricity in this case. So that's an exception to the rule of using the letter E. So a circle is perfectly round. It's going to have no eccentricity. It'll be 0. So how do you find the eccentricity? Well, it is always going to be it's the ratio of any point on the curve to the focus divided by the perpendicular distance from the point on the curve to the directrix. And yes, even hyperbolas and ellipses have directrix. They have directrixes. A hyperbola will have one in between the two curves. An ellipse will actually have two of them outside of the curves. But let's illustrate here with a parabola. So I have some point on my parabola going from there to the focus, and then I have that same point on the parabola that's perpendicular to the directrix. If we think about a parabola, any point on the parabola is always equidistant from the focus to the directrix. It's always equidistant. That's why a parabola will have an eccentricity of 1. It's always equidistant. Now, an ellipse has an eccentricity that's greater than 0 but less than 1. And a hyperbola has an eccentricity greater than 1. And eccentricity is always a positive value. How would you find the eccentricity? Well, it's going to be C over A. C is used from finding the focus, and then A is the length of your major axis. So let's get started with some examples. This shouldn't be a super long lesson either. I know the last lesson was horrifically long with the polar graphing, but this one shouldn't be nearly as bad. So we'll get started with some examples. First, let's do a circle, and we'll actually show you why it's 0. So let's pick a circle first. Alright, so I have x squared plus y squared minus 4x minus 6y minus 23 is equal to 0. Okay, well, let's simplify this a little bit. So we'll have x squared minus 4x plus y squared minus 6y equals 23. Let's complete the square to get this into a form of a circle. So you would have x squared minus 4x, half of negative 4 is negative 2, square that, you get positive 4, plus y squared minus 6y, half of negative 6 is negative 3, square that, you get plus 9. That would equal 23 plus that 4 plus that 9. Alright, so this would simplify into the quantity of x minus 2 squared plus y minus 3 quantity squared is equal to 36. And as we see, we definitely have a circle. do we remember earlier in this unit when I talked about how you could think of a circle as an ellipse with both axes having the same length? So both axes are your major axis. So let's treat this like an ellipse for a second. Let's get the right hand side equal to 1. This would turn into x minus 2 quantity squared divided by 36 plus y minus 3 quantity squared divided by 36 equals 1. So we're treating this circle a lot like an ellipse, okay? Well, here's the thing. We can see that, again, a circle, both the x and y axis are the major axis. They both have the same length. Well, having said that, how do we go about finding the focus of an ellipse? It's always going to be c squared equals a squared minus b squared. Well, it doesn't matter which one we call a, which one we call b. Both of them are 36, right? So c squared would equal that 36 squared minus 36 squared, which means c squared equals 0, so then c equals 0. Now let's find the eccentricity. Well, if c is 0, a is, well, it's not 36 squared, it's just 36. I don't know what I was thinking. These are already squared. Ugh. Gosh, it's been a long week. Okay, 36 minus 36 is 0. Still, you get 0. We'll call a would be either, it'd just be 6 because we only consider the positive for eccentricity. Well, 0 divided by 6 is 0. So there is one example of how circles have an eccentricity of 0. And it doesn't matter what radius you choose. It doesn't even matter what its center is, any of that other stuff. The eccentricity of a circle is always 0. Okay, so we've talked about a circle. Why don't we go ahead now and talk about a parabola? So let's deal with parabolas. So let's see here. We have x squared plus 4x minus 8y plus 20 is equal to 0. So then let's get the y and the constant term by itself on the right hand side, since we can clearly see this is a parabola because there's no y squared term. So you'll have x squared plus 4x equals negative 8y minus 20. Now let's complete the square on the left hand side. So you'll have x squared plus 4x plus 4 would equal negative 8y minus 20 plus 4. So then this would turn into x plus 2 quantity squared equals negative 8y minus 16. So then you could end up getting x plus 2 quantity squared equals negative 8 times y plus 2. And we put that parabola into standard form. Well, let's pick any point on the curve. First of all, what we should do really, is find a point on this parabola. We know that the vertex is going to be, for this parabola, is obviously negative 2, negative 2. What I'm trying to show you is why the eccentricity is always 1. Okay, so we should probably now find the focus. Well, the focus is going to be, it's always based on 4p equals that negative 8. So 4p equals that negative 8. So p would equal negative 2. So you'll add that to the y-coordinate of your vertex to get your focus. Your focus is going to be negative 2, negative 4. And then to get your focus, you'll subtract that negative 2 from the coordinate, the y-coordinate of your vertex to get your directrix, rather. So your directrix would be at y equals 0. Okay, so now that we found the directrix, let's go ahead and set out to prove how this equals 1. Again, for any curve, the eccentricity equals the ratio of the perpendicular, and the ratio of any point on the parabola to the focus over the perpendicular distance of that point to the directrix. Well, let's take any other point. What if I pick, let's say, let's make y negative 4. No, y is negative 4. Okay, so that would just give us the focus. I'm trying to pick another point. Heck, we can pick any point. Why don't we pick the vertex? The vertex is on the so the vertex is on the parabola. So let's go from the vertex to the parabola. What's the distance from the vertex to the parabola? The distance from vertex to the focus. So if I make my x2 negative 2, I'll use the distance formula. Negative 2 minus negative 2, that'd be negative 2 plus 2 quantity squared. Plus, now if I take my y2 of negative 4, so that'd be negative 4 minus that negative 2. Well, that'd be negative 4 plus 2 quantity squared. That would end up equaling the square root of 0 squared plus negative 2 squared, which would end up giving me the square root of 0 plus 4, square root of 4, which equals 2. So the distance itself from the vertex to the focus, it has a distance of 2. Now, what about from, let's take that vertex which is on the parabola to the directrix. Well, directrix runs through y equals 0. You could pick any x point on that directrix, so why don't we pick negative 2, 0? We'll pick negative 2, 0. So the distance from the vertex to the directrix, let's use the distance formula again. So if we make the directrix our x2, we'll take that negative 2 minus the negative 2 from the vertex, so that's negative 2 plus 2 quantity squared, plus, now if I take my y2 of that 0 on the directrix, minus my y1 of the negative 2 on the vertex, 0 minus negative 2, well that's 0 plus 2 squared. So that would end up giving me the square root of 0 squared plus 2 squared, which would give me the square root of 0 plus 4, which would end up giving me the square root of 4, which would give me 2. So the distance from the vertex to the directrix also is going to be 2. Well, 2 divided by 2 is 1. So that is just one example of how a parabola has an eccentricity of 1. And you pick any parabola anywhere, no matter what you're given, you're going to get an eccentricity of 1. Because the vertex, which is a point on the parabola, as we know, is equidistant always from there to the focus and from there to the directrix. Now, where it gets interesting is when we get into ellipses and hyperbolas. That's really where we're going to focus these next 4 exercises. So let's do a couple of ellipses. Alright, so I have 9x squared plus 4y squared minus 18x plus 16y minus 119 is equal to 0. Well, we can very clearly see that this is going to end up being an ellipse. But let's work on simplifying it because we need to get our A, B, and C. So, okay, let's go ahead, let's simplify this by getting the x and y terms together. So you'll have 9x squared minus 18x plus 4y squared plus 16y would equal 119 if we get rid of the constant out of the left and move it over to the right. Now on your x terms and y terms, factor out what you can factor. You should always get a 1 on your quadratic term, so factor out a 9 for your x terms. It would be 9 times that x squared minus 18x. Actually, no, that'd be 2x. X squared minus 2x. And then your y's, you can factor out a common 4, so plus 4 times y squared plus 4y equals 119. Alright, now let's complete the square for each of these quadratic terms. So you would have 9 times x squared minus 2x, that would turn into plus 1. Plus 4 times y squared plus 4y plus 4 is going to equal 119 plus 9 plus 16. Now let's go ahead and simplify these. On the left hand side, you would get 9 times the quantity of x minus 1 squared plus 4 times the quantity of y plus 2 squared equals this side, 119 plus 9 is 128, plus 16, that's 144. Now all we have to do is make the right hand side equal to 1, so if we divide 144 by 9, you should end up then getting x minus 1 squared over 16 plus y plus 2 quantity squared divided by 36 is equal to 1. Now we have this ellipse in a form we can work with and use to find the eccentricity. Well, we know our a squared is 36, and since we're only considering the positive values because the eccentricity is always positive, that means a is going to equal 6. Our b squared is 16, and again, we're only considering the positive values here, so b squared is 16, so that means b would equal 4. Now, how do you go about finding c squared, which is to get your foci of an ellipse? Well, that is always c squared equals a squared minus b squared. So c squared equals, the a squared is 36 minus b squared. which is 16. So c squared equals 20. And again, we're only considering the positive aspects for the fact we're going to find the eccentricity. So c would equal the square root of 20, which is really the square root of 4 times the square root of 5. That would give you 2 times the square root of 5. All right, so we found c. We also have a. Well, the eccentricity is always going to be that c divided by a. C is 2 times the square root of 5. A is 6, so you'll have 2 times the square root of 5 over 6. This would simplify into the square root of 5 divided by 3. Now, usually they like a decimal approximation. We can clearly see it's going to be less than 1 and greater than 0, but let's get a decimal approximation. What is the square root of 5? All right, let's take that divided by 3. You get an eccentricity of approximately 0.75. Usually when they ask for the eccentricity, they're going to want it to 2 or 3 decimal places. So, yes, this ellipse has an eccentricity of approximately 0.75, which for an ellipse, that follows under the conditions for eccentricity being greater than 0 but less than 1. And this is greater than 0 but less than 1. So in this particular ellipse, it's 0.75 approximately for the eccentricity. Let's do another ellipse. Then we'll do 2 hyperbolas, then we'll be done. Alright, so we have 4x squared plus 25y squared plus 16x plus 250y plus 541 equals 0. Got some big numbers in there, but that's okay. What we're going to do is simplify this like we normally do, get your x and y terms together, and then get the constant term over to the right-hand side. So this would turn into 4x squared plus 16x plus 25y squared plus 250y equals negative 541. Alright, so now let's factor out what we can factor from the x and y terms. So on the x's, we can factor out a 4. You'll have 4 times x squared plus 4x. Now on your y's, you can factor out a 25, so plus 25 times y squared plus 10y equals negative 541. Let's complete the square, so you'll end up with 4 times x squared plus 4x plus 4 plus 25 times the y squared plus 10y plus 25 equals negative 541. But we got to add these other terms from completing the square, so this would be plus 16 plus 625. So we simplify this, you'll end up getting 4 times x plus 2 quantities squared plus 25 times y plus 5 quantity squared is equal to the right-hand side. Alright, so negative 541 plus 16 plus 625 gives you the right-hand side equaling 100. So the right-hand side equals 100. Now to turn this into an ellipse we can work with, we'll divide both sides by 100, make the right-hand side equal to 1. So if you do that, you'll end up getting x plus 2 quantity squared divided by 25 plus y plus 5 quantity squared over 4 equals 1. Now we have a form we can work with. Let's go ahead and identify our a, b's, and c's. Well, a squared equals 25, and since we're going for eccentricity, we only consider the positive root, so a equals 5. And then, of course, b squared equals 4, which means b would have to equal 2. We really didn't need to find b, but we did need b squared. Alright, so that means c squared is going to equal a squared minus b squared, so that'd be 25 minus 4, which would be 21. So c would equal the square root of 21, and again, we only consider the positive root when going for eccentricity. So now let's find the eccentricity. That's always c divided by a. Well, c has the square root of 21 as the value. A is 5, which this will definitely be less than 1, but let's get a decimal approximation for this eccentricity. So you get an eccentricity, if you're rounding to 2 decimal places, of about 0.92. So the eccentricity for this parabola, this ellipse rather, comes out to about 0.92. Greater than 0 but less than 1. So this is definitely an ellipse. Alright, so the last two I want to focus on are going to be hyperbolas for the last 2 exercises. So we talked earlier in the lesson how a hyperbola has an eccentricity greater than 1. Well, we'll show you how that works. So let's do some hyperbolas. We have 16x squared minus 9y squared plus 32x plus 54y minus 209 equals 0. Well, let's go ahead and simplify this. Get your x and y terms together, get the constant over to the right-hand side. So you would end up having 16x squared plus 32x minus 9y squared plus 54y equals 209. Now let's factor out the 16 on the x's. So you would have 16 times x squared plus 2x. Factor out the negative 9 on the y, so you'd have minus 9 times y squared minus 6y equals 209. So let's go ahead and complete the square. You'll end up having 16 times x squared plus 2x plus 1 minus 9 times the y squared minus 6y plus 9 is equal to 209 plus that 16 minus 81. Let's simplify now. This will become 16 times x plus 1 quantity squared minus 9 times y minus 3 quantities squared is equal to this 209 plus 16 minus 81. I have a pretty good idea of what it's going to be, but I just want to double check. Yep, just what I thought it was going to be, 144. Of course, for a hyperbola, to be able to get our lengths and foci and all that, we need to make the right-hand side equal to 1. So divide both sides by 144. If you do that, you'll get x plus 1 quantities squared divided by 9 minus that y minus 3 quantities squared divided by 16 equals 1. Now we have the form of a hyperbola that we can work with. Well, our a squared is going to be 9. So a squared equals 9. And since we're going for eccentricity, again, we only consider the positive root. So a equals 3. B squared equals 16. We don't need b, we just need b squared, because to find the foci of a hyperbola, c squared this time equals a squared plus b squared. Well, a squared is going to be 9 plus 16 for your b squared, which would give you 25. So c squared equals 25. That means c equals 5. And then last but not least, let's find the eccentricity. That's always c divided by a. Well, c has a value of 5. A has a value of 3. Well, 5/3, that's 1 2/3, so that's approximately 1.67. So for this particular hyperbola, you get an eccentricity of about 1.67, which is greater than 1. That's the eccentricity a hyperbola would have, greater than 1. Let's do one more hyperbola, then we'll be done with the lesson. Alright, we got y squared minus x squared plus 2x minus 6y minus 8 equals 0. So y squared minus x squared plus 2x minus 6y minus 8 equals 0. Well, we definitely have a hyperbola. Let's get the x and y terms together and get the constant term over to the right-hand side. So this would turn into y squared minus 6y minus x squared plus 2x. That's going to end up equaling 8. Now let's complete this. Well, first let's factor out what we can factor. The y's already factored. You'll have y squared minus 6y. We'll just put parentheses around that for good measure. Now the x, you can factor out a negative 1. So that'll be minus the x squared minus 2x would equal 8. Now let's complete the square. So you'll end up with y squared minus 6y plus 9 minus, then you'll have the x squared minus 2x plus 1. That's going to equal 8 plus 9 minus 1. So if we simplify, you'll get y minus 3 quantities squared minus, you'll have that x minus 1 quantity squared is going to equal the right-hand side, which turns out to be 16. Alright, well, we need to make the right-hand side equal to 1, so let's divide both sides by that 16. You'll get y minus 3 quantities squared divided by 16 minus the x minus 1 quantity squared over 16 equals 1. Now we have this hyperbola in a form we can work with to find the eccentricity. Well, a squared is 16, which means that a would have to equal 4. Then b squared also equals 16. Well, to find the foci again, c squared equals a squared plus b squared, so 16 plus 16, which is 32. So c is going to equal the square root of 32, which is the square root of 16 times 2, so that's 4 times the square root of 2. And now we can go ahead and find the eccentricity. Eccentricity equals, of course, c over a. Well, c has a value of 4 times the square root of 2 over your a, which just has a value of 4. And we know that's going to simplify into the square root of 2, which is greater than 1. But let's get a decimal approximation of 2 decimal places. Square root of 2 is about 1.41. So you have an eccentricity of approximately 1.41 for this hyperbola, which fits with the narrative, what they tell us, that eccentricity for a hyperbola is always greater than 1. Alright, so the reason we did this lesson is it's going to tie into the next lesson, which is going to be about the polar equations of conic sections. So yes, you can do these in the polar realm too. And those equations rely on eccentricity. So that's why we learned eccentricity. So I hope everybody has a great day. Take care.